Okay, back on track. You guys are talkative, which is good and bad. All right, a polynomial has non-negative integer exponents. Non-negative integer exponents. So no x to the 1/2. Of course, that's the same thing as the square root of x. X to the negative 1 is 1 over x. 1 over x squared. You can't have any of that stuff. That's not a polynomial. And then definitely no other crazy things like logs or sines or cosines or anything. Only x's. Only x with a positive or 0 exponent. That's what makes polynomials. The degree is the highest power for all the terms. Be careful about the sum of powers. I would stick with highest power when it's multiplied out. I think why it says sum of powers is if I had x squared plus 1 times x cubed, what's that degree? What's the degree of that polynomial?
3, 5, 6.
Oh boy, we got all kinds of answers.
6. I have no idea. I don't even know.
Let's multiply it out first, maybe that'll help. What's x cubed times x squared?
X five because it's parentheses.
Because it adds, right?
X to the 5th?
Sure.
Yes.
Ryan left his brain in the Bahamas. It's not a bad place to leave it, but go get it back. So now what is the degree of that thing? Well, be careful. You don't say the degree is x to the 5th. You say that the degree is 5. It's the power, not the variable with the power. And so I don't like that it says sum of powers. I know why it says it, but highest power is the better way to phrase that. All right, some terms that I think you know, most of these. Degree 0, so that would be like if you had 3x to the 0. Well, that's the same thing as just 3. X to the 0 would be 1, but then times 3 would be 3. So that's a constant. These maybe should not necessarily go together. Like I don't like that this, because you could still have a different number of terms. One term monomial. So let's treat them separately because they are separate. So x to the first would be linear, x squared, quadratic. Then we start getting into some weirder names, maybe. X cubed is cubic. I guess that one's not too bad. X to the 4th. I guess that's close, maybe. Quartic. You're not going to need to know the name quartic. Any guess on the 5th? Penta is a great guess. But quint. Quintic.
I don't even know what that looks like.
On a graph? Well, on a graph it would have 4 turns, so it would look like 1, 2, 3, 4. There's a quintic graph. We're not going to have to worry about that. Let's come over here and work on our some more prefixes here. Monomial, mono, 1, binomial, 2, trinomial, 3. I think quadrinomial. I think at some point you don't worry about how many, you just call it a polynomial. That's right. Quadranomial. And the 5th one, I don't know. Pentanomial, a quintinomial.
Let's just keep it quintinomial. Same as the other side, right?
Let's just chicken out and call it a polynomial. That's kind of cheating, though, because all of these are polynomials. So you should be careful with that. even though poly means more than one, a monomial is still a polynomial. That's, I don't know, always thought that was a little weird. But polynomial would be all of those. Any of those, maybe. So some examples of polynomials. Y equals 3x cubed minus 2x plus 7. Right, that's a polynomial.
That's a trinomial.
That would be a cubic trinomial. Yeah, that's correct. Y equals 47 x to the 123 minus 12. I mean, it's a binomial. I can say that. I don't know what power 123 would be, so we would not worry about labeling that one. Let's be careful. There's also some non-examples. Some not examples. Sure. X to the negative 4. That's not a polynomial. Because that x to the negative, put it at the bottom, so that wouldn't work. And like a fraction wouldn't work either, so x to the 2/3. Ooh, I don't know if it's on this test, but in years past, there's been an example that really gets people. Y equals 3. That's a polynomial. It's a pretty simple polynomial, right? Because it's a constant, it's a monomial, there's not much there, but you still classify that as a polynomial. I guess one more in the not column would be anything with signs in it. Sine of x plus log of x plus e to the x. Any of those kind of things, definitely not polynomials. The rest of the stuff is pretty much a review of things you've already seen, but things we might need to remind ourselves about. X plus y squared. You know what? Let's say what it's not first. What does the uninformed math student think that the square of x plus y is? Yeah, none of you would ever make this mistake. I hope. Never. But some people think that's x squared plus y squared. You can't. You have to FOIL it. So what would it be? There would be an x squared. How many xy's? 2 xy's plus y squared. What about xy squared?
That's just xy squared.
Wait. Can I distribute? Can they both be squared, I guess, is the question? X squared, y squared. This is sort of one way to remember this, PIMDAS, which I will never write it out on the line because people get confused. I write it like that. You can distribute exponents to multiplication. That works. You can distribute multiplication to addition or subtraction. That works. But you can't distribute exponents to addition. That was that example. You can't do that. No skipping steps. So you can distribute like over one step, but you can't make that leap. The rest of this stuff is old news, or should be old news. If you do my popsicle sticks to get our new people in the right bucket. And I appreciate that volunteer. That's kind of you. Let's pick on two people here. Ryan for the numbers and Jan5 for the letters. So Ryan, what do we do with the 5 and the 3? It is 15. track. Jan5, what about x squared times x to the 7?
Oh,
You do. So what do you get? Is that better? X squared and x to the 7? X to the 9. There you go. Yep, again. Old news, mostly review kind of stuff here. I don't know. Is there any more? Like it's kind of all reviews. Like how much do we really need to say? Just reviewing. Good with all that. Why don't we just go to the homework and do some of that together? How about that? Not the homework. It's called the assignment. Tuesday, 1/7. It's only one page, just the front. Yeah, those are different days. So 1 through 3, if it's a polynomial, say if it's a polynomial. If it is, state the degree. That's, well, I guess we could do some of these as we go here. Maybe we'll do one from each section. So, Carson, number 1, is that a polynomial? Yes. And what is its degree? Degree 3. Yep. Is that what he said?
Yeah.
Okay, that's what I thought. Let's see. One from the next section. That's a lot of problems in there. Don't know what the degree is on 4? Well, first, is it a polynomial? Yes. And its degree is 5. It's the biggest power. Be careful.
That's right, because they don't force.
Don't say it's the biggest number, because it's not. The degree isn't 7. The degree is 5. Biggest power, biggest exponent. All right, you tell me. What do you want from 5 through 13? Not all of them.
7. Yes.
7? All right.
Ooh, 7's actually kind of easy.
I don't really think you want 7. There's some worse multiplication coming up.
11. 12.
12, you're multiplying 3 terms. That's kind of annoying.
Yeah.
I guess let's do 12. That probably is the worst one. So, multiplying 3 polynomials, in some ways it's a little bit like multiplying just 3 numbers. If you do 3 times 2 times 4, what's the answer to that? 24. How'd you do that?
3 times 2 and then.
Right, 3 times 2 is 6, and then multiply by 4. So, like, even though you're multiplying all 3, your brain doesn't really multiply all 3 at once. Like, you have to pick 2, and then get that answer, and then multiply it by the third one. And it's the same thing with 3 more complicated terms. You can't do them all at once, just like you can't do 3 times 2 times 4 all at once. You have to pick 2, do 2, and then do the third. So we'll do the same thing here. It doesn't matter which 2 you pick, just like with the numbers. You could have done 2 times 4 and then times 3, or 3 times 4 and then times 2. Like, you always get the same thing. So which 2 you do first doesn't matter, but I feel like probably doing the A's and B's stuff first is probably the best bet. So 2a squared plus 3ab plus 2ab plus 3b squared. We're going to have a lot of terms in this when we get done. That can simplify a little bit. 2a squared plus 5ab plus 3b squared, and then times 2x minus y. Lovely.
Easier to multiply 2xy.
Yeah, that's what I think too. Like, I mean, it doesn't really matter, but I think just conceptually, I would distribute the 2x to everybody, and then the minus y to everybody. Is that what you mean, Ryan?
Yeah.
Say that? Or
I'm not Ryan.
You're not Ryan, you're Jack. So let's do the 2x to everybody first. So that's going to be, well, careful, 2a squared times 2x. 4a squared x. I don't know that we're going to have any like terms when we're through with this. I don't think we are. And then 5ab times 2x. Let's pick on people, because we can pick on people for days with us. Cash, what's 5ab times 2x? Yep. Nicole, how about 2x times 3b squared?
6b squared x.
Yep. Next up, we'll multiply that minus y to everybody. So make sure you keep that negative on there.
So that's
So,
Six.
Reese, yeah, it is going to be 6 terms. Reese, what's negative y times 2a squared? Good. Harris, how about negative y times 5ab? Yep.
I said before you're clean college.
And Adeline, what's negative y times 3b squared? Yep. And then as we already kind of saw and you figured out, there's no like terms in there. There's only one term with there's a squared, but x and y. There's no abx's. Yeah, that's it. 6 terms. Lovely. But hey, it's the worst one and we did it together, so all is well. All right, how about one from the final set there, 14 through 18?
I mean, I think we already had that.
I mean, we just did a bunch of those, but we can do one more. Which one do you want? 15? The negative in there?
Ooh, I love them.
Which one did you like?
19 looks not wrong. I don't know.
Dude,
I just did it in my head in 1 second.
It's really easy.
These are 5 from 40. Here, I'll
Don't call out the answer. Let him work for it
call it
first.
out. He's gonna. I can borrowing it. I'll give it back.
Well, all right. Well, then I'm going to pick. Let's do 15. So, I guess this is you can clean up the inside first and then do the -3, or you can do the -3 and then clean up. I usually clean up first. So, let's keep picking on people here. Luciana, how about the A's? How many A's do we have and where are they? Well, this is a to the -7 and that's just a, so when I put them together, do you remember what we do with a to the -7? What the negative does? Yes, put it under. And so now how many a's are in the bottom? Well, we moved 7 down there, but there was already 1 down there. So 8. Cooper, how about the b's? How many do we end up with?
8.
Top or bottom? Leave the 8 in the top. And then everybody can get the -3. And we can't leave negative exponents, so we need to flip those things around. So a to the 24th in the top. Anybody know what 5 cubed is? 25. B to the 24th in the bottom.
Why can't we can't have a negative and
We don't like a negative exponent,
well,
so we move things around.
well, technically, could you have -120? Oh wait. That's fine.
Careful, negative exponents flip it over. They don't make the base negative. Jack, did you figure out 19, or we need to look at that? Okay. Anybody else want to look at 19?
No, he's got it. No, he got it.
No, Jack has it. Okay, so today's assignment is the rest of that page. Hopefully you're close to done.